Good morning, class. Today we're going to talk about triangle trigonometry. So this is a review from geometry, which was a long time ago, but I expect you to remember it. That was a good joke, wasn't it? Alright, so let's look at this triangle. You all learned SOHCAHTOA, right? Long ago and far away. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. And this only works for right triangles. And when we say opposite and adjacent, we're referring to an angle that you have chosen. I could choose this top angle just as well as this bottom left angle, okay? So let's look. Sine of theta, so that would be opposite over hypotenuse. The opposite side is 4. So I put 4 over 10. 2/5. That's nice. Okay. Cosine of theta, right? Adjacent is the one next to, touching the angle. So adjacent over hypotenuse. Well, I've got the 10, but I really wish I knew what x was. Well, it's a good thing I paid attention in, I don't know, both 7th grade and geometry, because I learned something useful then. How would you take these two sides and find x? Pythagorean theorem? I like it. Alright, so we'll do x squared plus 4 squared is equal to 10 squared. Okay, I've got x squared equals 84. I'm taking the square root. I don't obviously need the negative. 84 breaks into 2 root 21. Okay, so I know that my adjacent side is 2 root 21. I'm going to write it right here, 2 root 21, the adjacent over the hypotenuse. So my cosine simplifies to the square root of 21 over 5. Alright, now for tangent, I know that I'm looking for opposite over adjacent, and I know the opposite side, the one opposite the angle is 4, and the side adjacent to it is 2 root 21. This is not simplified, so 2 over square root of 21. But I'm going to ask you especially in trig, to rationalize denominators. So I'm sorry, but we need to. So to get rid of that square root, you multiply by the square root of 21. You did a lot of this in geo, I'm hoping, so I hope it's a refresher. Okay, so there's my tangent. Alright. So say I wanted to find theta. I wanted to find the value of the angle. I could use the sine ratio, because we have that, the cosine ratio, we've got that, or the tangent ratio. None of them have variables in them other than the angles. So I have all 3 of them, I could use any of them. Sine looks the simplest, but I'm going to get the same answer regardless of which one I use. So if I'm looking for theta here, I need to get rid of this sine. To cancel out a function, you have to take its inverse, right? So if I apply the inverse sine to this side, they cancel, and I get the inverse sine of this thing over here. Whenever possible, I'm going to ask you to write this line and type this fraction into this, this function just like this. Instead of getting the decimal here and then taking the inverse sign of the decimal. It's going to keep you from having rounding errors that will cause you to lose points on later tests. So take my suggestion, make sure you leave everything with square roots and fractions and all that stuff until you actually get to this step, and then type it all into your calculator at once. Alright, let's do some word problems. Let's do one of those classic flagpole problems. How high is the flag, or how tall is the flagpole? So this is you, excuse my drawing, and you're looking at a flagpole over here. It's 40 feet from where you're standing. You are, I don't know how tall, but let's say that your eyes are 5 feet 4 inches from the ground. Five feet 4 inches. And if you hold a clinometer, which could be your iPhone, up to your eyes and aim it at the top of the flagpole, you get an angle of 29 degrees. So, assuming the flagpole is standing upright, a right angle there, assuming this is parallel, we've got a right angle there. Great. I want to figure out the height of the entire flagpole, but I don't have a triangle with the whole flagpole. I just have this one, so I can use this. Let's see. This is 40. This is 29 degrees. Which side do we want to find? No? Okay. We'll find this one. Let's call it x, just for fun. Sine, cosine, or tangent? Well, we don't know anything about the hypotenuse, so, S-O-H, can't use that. Ca, C-A-H, can't use that. So we're using tangent here. Tangent of 29 degrees is equal to opposite, so cross from it is x over 40. Okay, so x is equal to, I'm going to cross multiply, you get 40 tangent of 29. Great, 22.17 feet. But this is 5 feet 4 inches, so the whole thing is 22.17 feet plus 5 feet 4 inches. 0.17? I have to figure that out, right? So let's do that now. Let's figure out what that is in inches. Okay, 22 feet and 0.17 feet. So this converted 0.17 feet into inches. So I want to multiply by, there are 12 inches in 1 foot. So do I want to put the feet up here and the inches down here, or the feet down here and the inches here? We want this feet to cancel, so feet have to go here to end up with inches, and it's 1 foot to 12 inches. 2.04 inches, and I'm going to call that 2 inches. Okay? It's not like your clinometer measurement was that accurate. So we've got 22 feet, 2 inches, plus, because that's this part, right? Plus the 5 foot 4 inches to your eyes. And what do you come out with? 27.5 feet. 27 feet, 6 inches. Height of the flagpole. So far we've talked about sine, cosine, and tangent. But there are 3 other trig functions that no one has mentioned to you yet. They're so similar to sine, cosine, and tangent that they're not a big deal. But their graphs are kind of cool, so let me show you how to use sine, cosine, and tangent to create their connected functions. I'll let you see what it is. So sine is the ratio of the opposite side over the hypotenuse. If you want to create one of the new functions, all you do is turn it on its head. You get the hypotenuse over the opposite. That has a name. So essentially, these 3 new trig functions are just the reciprocals of the old trig functions. So the easiest one to remember is the opposite, or the reciprocal of tangent, right? So instead of opposite over adjacent, we'll have adjacent over opposite. And this function is called the cotangent. So tangent, cotangent. Well, so this would be really simple if you took like tangent, cotangent, and sine, and cosine. Oh, we already have one of those. So that's not going to happen. But the way I always think about this, there are two trig functions with s, starting with s and c. Two of the reciprocals also start with s and c, but they go opposite each other. So this one starts with s, this one starts with c. This one starts with c, this one starts with s. This one is called secant, and this one is called cosecant. And of course the secant is the reciprocal of cosine, so that would be hypotenuse over adjacent. So far so good. Flip sine, you get cosecant. Flip cosine, you get secant. Flip tangent, you get cotangent. All right?